Good morning, judges and panelists. So I'm Jeffrey from final thesis. So today I'll be presenting my final thesis project. It's a service apartments. So to tie back with my previous dissertations, so I will talk about the elderly housing in Malaysia. So the problem now is that the elderly population are getting grow as per study in the last dissertations. The statistics show that the elderly aging in Malaysia actually increased in a recent year, and the housing for the elderly actually is not meant to be designed for them. So my design aim is to improve the elderly housing design, and my design objective is to find out the current housing guideline, why they are not suitable for Malaysian citizens. Secondly is to discover the ideas based design, and the third is to find a solutions in architectural perspective. So here we also talk about the daylighting design approach. This is 4 main elements: building orientations, light harvesting, and passive design, and the luminous level optimizations. So this is a design issue. So the statistic show that the increase of aging populations to those the years. And here they show that there are more, expected to be more. And the second thing is the lightings of the sources. So from the picture, you can roughly see that the light actually affect the visual of the elderly. The correct lighting use will be a huge impact, especially to prevent them from falling or injured in the home. So the unit design considerations, there are the few. First is the wheelchair accessibility. So I'm following the standard of ADA. So the unit shall be wheelchair accessible. Secondly is the corridor guideline for emergencies. So in case of emergency, how the bed toilet to access the units and to be efficient. Then the third, of course, is the lighting illuminance. So using the guideline of IESNA for this is purposely for the elderly. But for Malaysia ones, this is only for the standard. So I prefer use to the experts standard for the elderly. The next is a housing system. This is all from my previous predecessor study. Here it shows that actually the unit with more partitions, which have less light penetrations inside the room. So the less partition, the better the light harvesting. And this is a type of senior housings. So there are few type actually in Malaysia also. So in my proposal, I will cover the highlighted one, which is more commonly is the independent living and also assisted living. And so this is the type room. It's supposed to be the opening required to achieve the recommended lighting. So this is a case study of the one of the project by Woha in Singapore. So site analysis, this is a previous one. The site is located at Jalan Ampang. So my proposal is in the middle here. This is a perspective. You can refer in my slide. So this is a requirement for the car park parkings. I have 2 basement of car park. My density is low, so able to achieve the minimum car park with 2 floor of basement car park. This is a fire planning requirements. All the hydrant is placed near to the staircase. I have all the staircase planned, fire staircase, and also run distance. Then I have 2 protected lobby. One is here and one is here, and 2 access is for running. This is the sub basements. Then this is a ground floor. Ground floor is start from the fire engine access. So my building required islands. So with these routes, minimum of 6.1 meters access route, and the hydrant is no more than 90 meters. Then this is a tower planning. So my tower, there consists of 3 blocks. So I have compartment for each block. So in case of one block actually on fire, then they can actually go to the other block, since these 3 blocks actually linked together. So for the elderly, for using the staircase might be difficult, so they can run to the other tower to use the lift to go down. Then this is all the requirement. Is with sprinkler. All the development is with sprinkler. Hostel also provided. I have 4 set of staircase, fire staircase, 2 protected lobby. This is the water and sewage planning. So the domestic tank will be placed at the lowest basement floor, and pump up to the facilities intermediate tank and to the water and food supply. So the sewage pipe is direct discharge to the outlet to the STP. Then this is the sprinkler tank. So not just the tower itself, also the podium is all equipped with sprinkler system. Electrical. So the electrical, is placed at the site, so they can have direct access to the TMB stations, and all the wiring cable will be go through the riser. Is run from the ceiling side, then go up to the riser, then to the meter room, and distribute to all units. This is the development planning. So I have sunken the perimeter routes to allow my sub-basements. Then my M&E services can be placed at the sub-basement. Then the orientation is based on the simulations. Initially, it was designed to be side-by-side tower, but the lighting is blocking to each other. So this is the best way that to house all the lighting from the either side. This is the activity. There's in my buildings. I have a viewing deck. This yoga activity at the open area. Exercise on the ground floor, and kindergarten, reading rooms, gardening. There's a lot of gardening space, and a community hall at the first floor. So this is my tower planning. So my tower planning, I have 2 so-called emergency kit room. So inside that all the toilet bed and an emergency kit. So in case of emergency, there's a signal that alert it monitor room that will show later. That then they can direct come up here and use this for any of the rooms. This is an alternate floor. So in the middle here is landscape planning. Just the floor is the same, just that the landscape is a bit different. So they see the variance from the facade. This is a unit design. So the unit's design is to be small and efficient. Mainly is because want them to be easily to maintain. So this mostly will be occupied by 2 elderly. So this unit is more to those independent living who are actually still able to work or walk normally. So this is a transformable. So this is the first layout that all the places are open up. Secondly is that this wardrobe actually can be retract and move to front, then I have a study room here. And also this can be private to close up the curtain or insulate the bedroom living area. So in my emergency planning, then each unit have these built-in buttons for side, especially kitchens, bed, living, and bedroom. Then when in case of emergency, then the monitor room located at the first floor or the healthcare facilities area will be triggered, and the staff can direct go out to the lift and go to the unit desired. So this is a lighting simulations that shows that the unit can be achieved a maximum daylight harvestings. So less partition is better. This is the K unit is more for those assisted living. Consists of 2 floor. This is the first floor. This is the first floor plannings. So this is designed to be simple, only equipped with toilet and 2 bed and wardrobe. So the activity mostly will be on the care facilities outside. So this is the sub-basement floor. All the M&E is in this side, management room. Then this is go down to the basement, lower basement, and grow out from the lower basement. This is a ground floor. So I have a central garden in the middle. This is mostly a lobby and the grocery shop here. Then this is the first floor. This is where the facilities is. Then community space. This is a large space for them to hang around. And the kindergarten is here and the outdoor playground. Then intermediate here is like connections between this and this. This is more to like a gardening space, similar to the second floor. Still the facilities floor, the care facilities floor. Then this is a reading room. This is for the swimming pool upstairs. Then this is a facilities floor. Then this is a resting area. Then here also they like hang around gardening space. This is all the gardening space here. The swimming pool, the tower. Okay, that's it. Thank you.